All right, boys and girls. Hey, this is Mr. Bell, Mr. Bell's Math. I'm excited to bring you another edition of this world famous tutorial video podcast, whatever you want to call it. Anyway, I need to go ahead and get after it since I want to try to keep these videos a little bit shorter than I've been doing. These lately have been a little long, so if I ramble like I am now, they're going to get really long. So anyway, let's get started. This video is about prime factorization. Now, I talked to you in class, and I said I was going to do 2 different videos, but it looks like I could do it with just one. Just depends. So let's go ahead and get started. Prime factorization, the essential question. What I want you to know by the end of this video is how do you write the prime factorization of a number? Okay, so some things we have to figure out first before we can do that is how do you write factors of a number, just the regular factors. So whole numbers that are multiplied to find a product, all right? And I'm reading, in case you're not sure, I am reading this right here. Whole numbers that are multiplied to find a product, to find the answer of a multiplication problem, are called factors, all right, of that product. So it says a number is divisible by these factors. For example, 4 and 2, all right? If you multiply 4 and 2 together, they're 8. So 4 and 2 are factors of 8, because 4 times 2 equals 8. And 8 is divisible by both 4 and 2. Okay, so the first thing I want to do is I want us just to list all the factors of 21. Okay, that's the first question in the video. List the factors of 21. All right, so if you listed the following numbers, then you did well. All right, and this is how I usually like to do it. I usually like to start, well, if I can write first, here we go. Write, where's my pen going? Oh, I'm writing in white, no wonder. Let's write in black. So I want to start with the first obvious 2 factors, 1 and 21. And I usually set them apart because I like to work. I know I'm not going to have a factor that's going to be any bigger than 21, and I'm not going to have one that's any less than 1 because I'm talking about numbers that multiply together to give me the answer 21. Okay? So this is not even, so I know it's not divisible by 2. See, what I do is I'm dividing 21 in my head by certain numbers, okay? And I just start small. I start with 1. 21 is divisible by 1, all right? 21 is not, however, divisible by 2 because it's not even. So the next one is 3, all right? 21 is divisible by 3. So then I say, all right, what do I multiply 3 by to get 21? Well, I multiply it times 7, all right? And then I go through my list and I say, all right, what about 4? No, because 4 times 5 is 20, so it doesn't go to 21. What about 5? No, I just said 4 times 5 was, so 4 and 5 are the same thing. 6 doesn't go into it because 6 times 3 is 18, 6 times 4 is 24, so 6 doesn't go into it. 7 does, all right? And now I'm over here at this part of the list, so now I know I have all my factors of 21. So my factors are 1, 3, 7, and 21. Those are the factors of 21. That's not what I wanted to do. All right, so here's a situation where you might want to list the factors of a number. Okay, it says Anna wants to build a rectangular garden with an area of 24 square feet. So, it says, what are the possible whole number lengths and widths of the garden? So we're not talking about fractions here. We're just talking about whole numbers. All right, so the first step, it says, recall that area equals length times width. Okay, so the first thing I want to do is remember that area equals my length times my width. So for Anna's garden, 24 square feet is going to equal 2 numbers multiplied together. All right, that's what we know. The next thing we want to think about is all the factors of 24. It says list each pair only once. So I got, oops, I'm doing the wrong thing here. I want that. 24, I always start, like I said, with 1 times 24. And then I say, okay, I could also do 2 times 12. I could also do 3 times 8. And I can do 4 times 6. And then the only number I have left, see, and I'm going to show you this. So this is how I do it. It says you can also use the diagram to show factor pairs. And this is how I kind of think about it as factor pairs. So when I list my factors, I'm going to start here and here. And I know all my other factors are going to be in between those 2 numbers. Okay, so I won't have anything bigger than 24. So then I say, all right, my next number is 2 and 12. 2 times 12 is 24. Then I say, all right, and see, I'm going in order, 1, 2, 3. And if I just come to a number that won't go into 24, then I skip it. So 3 times 8 is 24. And then 4 times 6 is 24. And then the only number I got left is 5. And I can't multiply 5 times anything to get 24. So that's it. That's all I have to do. And that lists all my factors. So it says the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So it says the possible lengths of Anna's garden are, if the length is 24 feet, okay, like right here, whoops, let me do that again. If the length is 24 feet, then the width has to be 1 because the area is 24, so 1 times 24. If the length is 12, then the width has to be 2. If the length is 8, then the width has to be 3, and so forth. So that's a time when you would need, and those are all the different combinations she can make her garden and still have 24 square feet. All right, let's look at the next slide. Okay, so now we're going to talk about prime factorization. All right, prime factorization of a number. Is the number written as the product of its prime factors. Now that may sound a little crazy, but basically I'm saying that if I want to write the prime factors of a number, all I'm using is prime numbers. Okay, like in this last example here, I had numbers like 2, or not 2, but 4 and 6 and 8 and 12. So those aren't prime. Okay, 1, 2, 3 are all prime. So those are the types of numbers we're going to use. So it says, for example, the prime factors of 12 are 3, 2, and 2. And they might say, well, Mr. Bell, 3 times 2 is 6. All right, but these are all the factors. 3 times 2 is 6, but 6 times 2 is 12. So all three of these numbers multiply together to give me 12. All right, so it says the prime factorization for 12 is 2 times 3 times 2, or you could say 2 to the second power, because there's two 2's here, times 3. All right, and it says use exponents to show repeated factors. So we're going to use a factor tree, and this is the first thing that you're going to talk about is a factor tree to do prime factorization. So it says list the factor pairs of 240, but we're going to use a factor tree to find it. All right, so 240, I want to think about, hang on. Okay, so it occurred to me that I don't like that example. All right, because this is how I'm going to do a factor tree. If I want to list the factors, the prime factors of 240, okay, I'm going to draw a factor tree. The factor tree just basically, I start with a number at the top, and then I go through systematically each individual factor pair. So I'm going to start with the smallest number I can other than 1. So I'm going to say 2 will go into 240 120 times. Okay, so now I'm sitting there with 2 as a prime number, so I don't have to worry with that anymore. So 120 is not prime, so I get to continue to factor this out. So once again, I'm going to pick a small number. I know it's even, so it's divisible by 2. That's going to be prime, but 2 times 60 equals 120. And then I keep going. I can go 2 again. That's prime. 2 times 30. I can keep going. That's 2 times 15. All right, and I'm running out of space here. Let me see if I can slide this up. Grab it. Can it slide? Well, yeah, I'll just slide the whole picture. All right, so I can keep writing. Okay, so 2 times 15. 2 is prime. 15 is not. It has factors, so I can go, 2 won't go into it because it's odd, but 3 will, and 3 is prime, and then 3 times 5. Okay, and that's it. 5 is prime. So once I get down to I have all primes, I'm done. So then I just count up my numbers, and I say 2 times 2 times 2 times 2 times 3 times 5. Okay, this is my prime factorization of 240. But I can rewrite this using exponents. So I count 1, 2, 3, 4 2's. So 2 to the 4th power times, that's a multiplication symbol, 3 times 5. And if we go and check, we say 2 times 2 is 4. Use a pointer tool. 2 times 2 is 4. Plus 2 is, not plus 2, but times 2 is 8. Times 2 is 16. Times 3 is 48. And times 5 is 240. All right, so that's all there is to it. So 2 to the 4th power times 3 times 5 is the exact same thing. Another method is what we call the ladder diagram. All right, same concept, just a different shape basically. All right, so the ladder diagram looks kind of like this, and this may be too big, but I'll show you. So it says the ladder diagram is another way to find the prime factorization of a number. It says use the ladder diagram to, and I'll just do 240 again. All right. So what you do is you put the number 240 inside this little first, basically like an upside down division symbol. And then you want to pick the smallest number you can to go into it. So I got 2 will go into 240. Then you connect another ladder rung here. That'll be 120. All right, that's your answer. So then I say, all right, well, I know 2 will go into 120. So then I draw another ladder rung. 2 will go into 120 60 times. So then I say, all right, let's pick another number that'll go into 60. So 2 will go into 60 30 times. And then I want to pick another number. 2, once again, is still my smallest number. All right, I want to stick with small numbers. 2 will go into 30 15 times. And then I say, well, I can't go in with 2 because it's too big. Or not too big, but it's odd. So I don't want to pick 2. I want to pick another number that's small, 3. 3 will go into 15 5 times. Okay? And then you got 5 going into 5 1 time. And then once you get 1 down here in the bottom, you're done. And this is not part of your prime factorization. Okay? These are your prime factors here. So you list them out. 1, 2, 3, 4. So I got 2 times 2 times 2 times 2 times 3 times 5. Now I just rewrite this using exponents. I got 4 2s, so I say 2 to the 4th power times 3 times 5. All right? I mean, that's all there is to it. You have two different diagrams that you can use, a factor tree or this ladder diagram, right, to help you do factor trees or prime factorization. Once again, prime factorization, you always kind of want to start with your smallest number, and usually 2 or 3 or 5 or 7, something that's prime that you can use. Okay, so answer the questions and do your Cornell notes. Thanks a lot.